Hello everyone. Today is day 17 of our challenge, solving 30 days in 30 machine learning problems in 30 days. Let's start. So it says we have to predict diabetes onset using decision trees and random forest. If you remember, we have solved problems using decision tree and random forest individually. So this is going to be the first problem we will solve using both the models together. Let's start. I will use the chat GPT again. I'll say, hey, it is day 17 and here is the problem. My chat GPT is taking, no, it is not. So yeah, it is getting stuck a lot lately because maybe the context is too large for it to process at a time. I don't know, but yes, I'm sorry. Yes, so it says let's get started on day 17, which is predict diabetes onset using decision trees and random forests. And here's a step-by-step approach we can follow. So first is we can use the Paima Indians diabetes dataset, which is a popular dataset for diabetes prediction. It is available on the UCI machine learning repository or Kaggle. Okay. In past we have used datasets from this and mostly from Kaggle. And then in step 2 we will be processing the data, handle missing values if there are any. I'm sorry. I did not get enough sleep. So yes, let's start. The second point is the scale the data if needed. Okay, as decision trees are generally not affected by the scaling, but it might help performance. Okay, so decision trees, if you remember, they are affected by the features. They are, I mean, the label instead of uh, the range of the label. So we might not need scaling here. And random forest is a forest of multiple decision trees. So yes, second step is build model. So we will start with a simple decision tree, move to random forest for comparison. Okay, good. And then in the step 3 we will do what we will you measure the accuracy score, see confusion metrics, and understand classification report to see how the model is performing, as in how the precision is coming, f1 score. So yes, and recall value. So let's start. I say, let's first find out the data set from the Kaggle itself. Okay, just for a thing, I guess this is not I guess, but this is a classification type supervised learning, supervised problem. So yes, how many? Okay, let's download it. Has it downloaded? Yeah, it has. So let's open our PyCharm and remove it, and then move the dataset from the downloaded folder to our dataset folder of our repository. So let's do that. And downloads diabetes, move to our dataset. I should see the diabetes here. Yes. And let's create a new file, a Python file, of course, day 17.py. and add it to our repository. And yes, I should be like it should. Okay, let me let me import it and tell the ChatGPT about the structure of our data set, so that ChatGPT can help us with the exact structure. So yes, so I will start with first mentioning what the problem is. Problem is this, okay, and we got our data set from this Kaggle problem, okay. So we will import the library called pandas and refer as pd, not ps, pd. And then we will do what, we will load the data, which is pd dot read csv, and here we are saying it is going to be from the data set, and diabetes dot csv. We will print this head and run this file. So I'll move a little up this terminal section. Run this day 17 file, and I am getting error. And this is the reason I was getting error. I did not use the correct uh, backslash. So yes, uh, I'm going to say I have downloaded the data set, and here how it looks. Now let's start with code flow and do explain each step. So now let's wait what ChatGPT has to say here. Okay, it is generating. Good. We don't have to ask explicitly to explain the steps. It is going to be better for us only to wait for the chat GPT to generate the response again and again. Yes. So it says, hmm, so evaluating both the models individually and visualizing. Yes. Yes, yes, sounds great. So let's start with the step number one, and it says it is importing the libraries. Um, Problem. Predict diabetes in onset using decision trees and random forest. Okay, that's the problem. And the data set involves what we did not see what the data set looks like, right? So it has pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, diabetes, uh, pedigree, function, age, and the outcome. Outcome is going to be our target, and the rest of the features are going to be our features. So yes, first we have to import library. So what are we going to use? We will be using from sklearn model selection import test, sorry, train test split. We will use it to split the data into training and validation data. Then sklearn dot tree import decision tree classifier. It is a classification type problem. Then we will have sklearn dot ensemble import random forest classifier. Okay. And metrics. Now we will import from sklearn metrics. Import accuracy score, confusion matrix, and classification report. Sorry. From No, I guess we have imported everything. Uh, Now we need to import for plotting visualization. So import matplot.py plot as plt, import cborn as sns. We are going to use it for visualizing or build for drawing a chart, a heat map chart. So first we will do what? Load the data. We have loaded the data. Then we are going, and we did see the head section, as in how it looks like the first 5 rows of the data set. And so it says x contains the outcome, all the columns. X contains the feature list, is going to contain all the columns except outcome. Y is going to be the target column, and the label showcasing whether the individual has diabetes or not, which is, if it has the label, if the user has diabetes, it is going to be 1, otherwise going to be 0. So perfect. Now we will do what? Split the data into features and target. Step 2, split the data into features and target. So features is going to be x is going to be data, everything except the outcome. And what we have to remove the column, correct? Yes. Then let me move a little down. Then the target is going to be data, outcome column, and this is going to be our target, this is going to be our feature. Perfect. Now we will step 3, split into training and validation data set. And we will again go 20-80%, 20% for testing and 80% for training. So let's split x validation, y train, y validation, test train test split, the features list, the target list, and we want what? Yeah, the size is going to be 0.2, which is 20% for the testing, and the random state is 42, to make sure that whenever we are running our code, the outcome is going to be same for this line. Now step number 4, build and train the model, right? Which is build and train the model. Which model? Build and train the decision tree decision tree classifier. Yes. So what we'll do? We will do decision tree. DCISION. Yes. And we'll call decision tree classifier. We will say the random state is going to be 42 for the same reason, to make sure whenever we are running, it is going to generate the same output. And we will train the model on our x train the training data and the training features, the training target. And step 5 is going to be build and train the random forest classifier. We have already learned in detail about these two algorithms, so we are not going to go in depth. We do know it makes it what it does. It creates a collection of random decision trees on random features, and then the averaging. So if I'll go here, I'll go to my problem number 7, and here random forest. So I'll go, a random forest classifier is a powerful ensemble learning method that builds multiple decision trees and combines their result. Each tree is trained on random subset of data. That is why it is called as random forest, because multiple trees. Final prediction is made by averaging the prediction of all trees. Okay, so we have already learned it in detail. So let's create random the instance of it, random forest. Here the how many trees we want. We want 100 iterations to generate the trees, and we want the randomness to stay, as in we want it to generate the same type of output whenever we are running the script again and again. So let's train the model on it. Again, x train and y train. Same model we are running on both the, sorry, same data set we are using to train both of our models. Once done, this is to create 100 decision trees. Now let's make the prediction. Step number 6 is make the predictions. And first is decision tree prediction, and it is going to be decision tree predict on x validation. Decision and random forest prediction, and it is going to be on random forest predict x value on validation data. And then we are going to evaluate the model. Step number 7, evaluate the models. Now let's evaluate. First we are going to evaluate decision tree. So if you have been following, we do this by 3 metrics: accuracy score, confusion metrics to understand the false positive, false negative, positive, true negative, and then classification report to understand how our model is performing with precision recall value. So let's start. The accuracy decision tree accuracy is going to be accuracy score of the actual value, that is the, and the predicted values. So it has predicted this. The confusion matrix, dt confusion matrix, is going to be confusion matrix of the actual value and the predictions made from the decision tree. And the decision tree classification report is going to be classification report of the actual value and the prediction made from the decision tree. Now we will print it. Yeah. Decision DECISI 1 tree accuracy score is what dt accuracy, and I'm going to copy it and then paste it 3 times. This is for what? To mention confusion matrix, and remove it, and it is going to be dt confusion matrix. This is going to be classification report. Let's remove it, and it is classification report. Sorted, looks good. Now let's, similarly, before running the full code, let's do for random forest as well. Forest, so it is going to be uh, random forest, not this, random forest accuracy, uh, accuracy, and it is going to be accuracy score of the actual values and the predictions made from the random forest. Random forest confusion matrix will be the confusion matrix of actual values and the predictions made from the random forest. Now let's save our classification report, and it is going to be the classification report of the actual values against the predicted values of the random forest. Classification. Okay, now let's print it. Print random forest accuracy score, and it is going to be what? Random forest accuracy. And we will do what? We will again do same thing, copy and paste, and now print the confusion matrix for random forest matrix for random forest. Now and the classification report for random forest. Again same mistake, and it is classification report. Once done, we are going to run it. Okay, it is going to take time because we are experimenting with two models. So let's do what? Let's build the model also. Step 7, and then we will understand the output. Visualization, and visualization, we are building the confusion matrix of, I want to build the confusion matrix of random forest. So it is going to do that step by step, right? So build the confusion matrix of, we'll do what? Build the confusion heat map for confusion, heat map for confusion matrix of random forest. Okay, so we'll do what? We'll first draw a figure, and the size is going to be 10:7. Then we'll build a heat map. We'll say it is going to be the RF confusion matrix, random forest confusion matrix. Annotation, yes, we want the format is going to be decimal. Yes, the colors are going to be blues, and the stick labels is going to be no diabetes as in 0 and diabetes as in 1. So I'll go and copy it. Sorry. And same for y tiles, no diabetes for 0 and diabetes for 1. Then I'll say the x label is going to be predicted values, and the y label is going to be actual values, and then we will simply show the graph. No, I'm yet to do what? Have the title of the chart, and it is going to be the random forest random forest confusion matrix, and then we will simply show it. Let's clear the terminal and run it. Hmm. So this is how the forest is looking like. Let me save it so that I can use it to create my progress post. And now let's compare it. I do see, did I forget? I still see it. Let's comment it. So decision tree score is 74%. Random forest score is 72%. Strange. Decision tree matrix is looking like 75. Um, it has calculated as the non-diabetic correctly, and 40 as correctly diabetic, and 77 it has calculated non-diabetic, which is more than the decision tree but less diabetic. So there we have a scope of improvement. And false um negative is going to be 21, so it has increased the number of people it has diagnosed as. Let me rerun it, and yeah, let me rerun it and then print the same thing on the decision tree matrix. Maybe I can tell you better there, because I'll open the, and this is uh, the confusion matrix of our uh, random forest, sorry, of decision tree. So let me go back and open both the uh, s- uh, images. So this is not our, so first this is our random forest. Let me go and change it also. So let me go and change it, random forest, and this is decision tree. Random, this is decision tree. Okay, ci, okay, and let's run it. And this is our decision tree. Okay, and let's run it same on random forest. We'll run it again, and this is our decision. No, I'll change it to random forest, and done. So we see random forest and the decision tree. So this is our decision tree and this is our random forest. So let's understand both step by step. So first we will minimize this a little. Yes, and now we will minimize this a little. Okay, cool, understood. So looking good. Now let's explore it. So we see the decision tree is saying that it has correctly predicted 75 non-diabetic and 40 diabetic. It has correctly, random forest has correctly predicted 77 non-diabetic but less diabetic, which is false positive, which is, sorry, the true positive 34. So here it is not performing that great. This section, if we see the it has, the model decision tree has predicted 15 cases as non-diabetic, but they were diabetic in actual data. And random forest predicted 21 as non-diabetic, but they were diabetic. Same if we see this decision tree correctly predicted 24 as diabetic, but they were originally non-diabetic. And random forest predicted 22 diabetic, but they were non-diabetic. So this is smaller, but here the model could have performed better. So hang on. Me- So yes, I've taken screenshot. Let me go back and do what? Maybe do what? Maybe build more decision trees, and let's do what? Clear it and run. We want to see the better performance. Oh, see, now the model is doing a little better. uh, the model performance is coming as 73%, still not great. So let's do what? Let's explore the other options here, and we will do what? I remember we did a thing right with um sorry uh so they are like, um we can say that we want, we which argument do you think we should use here? There was an argument to specify max depth. uh, s- so I can ask ChatGPT maybe, hey, I ran everything, uh, and random forest is uh, perform forest accuracy is coming as 72, but decision tree accuracy is coming as 74. I also tried to increase the the decision trees count to 200, and now it the accuracy got improved to 73. How do I improve the accuracy? How do I improve the performance? Actually, not accuracy, because it is like a classification, so we have to look at the whole picture, like true positive, true negative, false negative, as we saw while comparing both the decision trees, confusion matrix, heat map graph. How do I improve the random forest performance model? So yes, so it says random forest has several parameters that can be tuned to improve performance. You can use number of trees. More trees might help, but after a point they return diminish. The returns are diminished. We can do with the max depth of a tree. Limiting depth can prevent the overfitting. So we might be overfitting. So let's do what? Uh, okay, so we can do cross feature importance and everything. Maybe we can explore and dedicate a whole new video for that. Hang on. But let's try this step for this problem and not make this problem a little complex. So define the parameter grid it has created. Now the parameter grid. Okay, so it is doing a grid search. Okay, where the classifier is this parameter grid, CV and this, and now fit best parameters best score. Oh, let's do this. Grid search. What is grid search? Grid search performs hyperparameter tuning to train and evaluate a machine learning model using different combination of hyperparameters. Okay, so it should like looks like we have never done it before. So the random forest model is not performing good in comparison to decision tree. Let's explore which parameters are good for training it using hyper tuning, using hyperparameter tuning, hyperparameter tuning. Okay, I am making the same mistake again and again. I don't know why is it giving error, the mistake. Okay, it is 1n. Okay, so let's start. So there are these parameters to define the depth so that we are not overfitting the minimum sample split, the minimum number of samples required to split an internal node, the minimum number of samples required to be a leaf node. So we will do what? We will do define the parameter grid. Okay, and we will do what? Param grid is going to be not a list, and first we will do what? An estimator, and so I'll copy it, I don't want to make any mistake. An estimator is going to be our, we will go from 100, we will try 200, 300 should be enough, yes. Then we will try what? Max depth. Max depth is going to be what? Either none, then 10, 20, 30. 10, 20, 30, which is the maximum depth of a tree. And if I say this is the number of trees, okay, and extra space, then we will go max sample split, minimum sample split, minimum sample required to split into two nodes, and it is going to be 2 5 10, 2 5 10. And minimum sample, I just don't want to make any mistake, and minimum samples leaf, minimum samples leaf, and it is going to be 1 2 and 4. This is required for what? Minimum number of samples required to split an internal node into two, and minimum number of samples required for a node to be a leaf node, right? So looks good. Okay, two spaces, remove one extra space, two spaces, so looking good. Now built our grid, parameter grid for testing. We already have a random forest classifier, so I'm going to remove here, so I'll do that here actually. I'll come back to this actually, and remove it. Okay, no, let's keep it as it is and create a new object of random forest. So we'll say random forest classifier. The randomness state is 42 to keep the randomness consistent. And then we will start with grid search. Grid search. So what it does, we saw that it evaluates on multiple parameters to see which combination is working fine, and the grids. So we have to import it, right? So from model selection we have to import grid search CV. From model selection we have to import grid search CV, and now we are going to use it, grid search CV. And here we specify which estimator we want, RF random forest, and the parameter grid is our parameter grid. The CV, uh, can you explain this please? Let me ask ChatGPT here. So it is a code for setting up grid search. CV is a technique used for fine tuning the hyper parameters of model to find the best combination of parameters that improve. Grid search validation. It is a method to systematically test different combination of hyperparameters to find the one that gives the best model performance. Grid search creates a grid of parameters values and train and evaluates the model using the every combination of these. So it tests the model on every combination for performance. It says it refers to the model you want to tune. In case RF stands for the random forest classifier. So grid search will be using RF model and test it with different hyperparameters combination. So this is going to be our parameter grid. Um, this is the number of cross validation folds. Okay, so what is it? Cross validation is a technique to split the data into several parts, in this case 5 parts of folds. The model is trained on 4 parts and tested on the remaining one part. Okay, the this process is repeated on each part, ensuring that every data point gets a chance to be in the validation. Okay, so the model split into four, and the one will remain into testing, so that every combination will be involved in evaluating the performance. So this is number of folds. The parameter specifies how many CPU cores to use for the computation. We say one only, because this one is so setting -1 means all available cores, making this okay. We do not want parallel computation. I don't know how good my system is going to perform. So I'll say okay, so we want all available cores. Oh, if you have multiple, it helps speed up this. Can we okay? Verbose parameter controls the amount of detail printing out during the search process. Okay, and a verbose level 2 print will print detailed output of for each fit and progress and the progress of the grid search. This is useful to track the progress, especially when you are running the time consuming grid search. Okay. Okay, so we want to get the output very in a detailed way. So we are going ahead with verbose 2. So let's start with how many folds we want. 5. How many CPU cores you want to run? Whatever is available, or how many are available. Verbose, we want detailed output, and then we are going to do what? We will print it. Yes, fit the model. Fit the model. So we will do what? Grid search. Fit on the exchange and validation the target, and then okay, get the best parameters and accuracy. Now just get the best parameters and accuracy, and we will do what? Print what? Best parameters are going to be grid search dot best parameter params, and then we will print what? We will print best score, and see how it is going to look. Grid search best score. Let's run the model now. Let me hide the visualization step, not show the model. Run it. Now let's wait. It is running. So that's what I guess the verbose is doing. It is showing the progress in a detailed way. See, it is trying on multiple combination, and the best parameter is this. So the best parameters are coming as this. So let me copy it and show. Output is this. Best parameter is none. So I'll go and specify best parameter here, the n estimator as none. Sorry, sorry, an estimator as 100 I was using. So 100, and max depth is none. So max depth is going to be none, and min sample leaf is going to be 1. Minimum samples are required to split. Minimum sample, sorry, to be a leaf node, and minimum sample split is 5. So let's go, and minimum sample space is 5. Now let's do what? Let's uncomment everything. Let's copy it, comment it, comment this also, and this also. Let's decrease the size. It is going to be 5, not 7, 5. Okay. Yes. And I want to see the both the graphs actually. And this is going to be decision tree confusion matrix, and it is going to be decision tree confusion matrix. Okay, let me correct the spelling. And decision tree, so first we'll see the decision tree. Decision tree, and this is again the same spelling mistake, random forest. Okay, let's run it. This is going to be our, sorry, let's save our decision tree, same thing that we have seen, and this is going to be our random forest. And we should see the performance here now has been improved from okay, 73%. The performance is coming as 73%. Strange. How? Why? N estimated 100, minimum split, minimum sample, max depth none. Six, 73, 73, 73, 73. Where did I make mistake? Okay, we do not see the change here. So here it is none. I'll not specify it. So maximum depth should be none, no? So it is default none only. Let's run it one more time. Huh? I want to see decision tree. I guess it did get improved. Strange. Even now the decision tree is not working as it is saying X train, Y train, evaluate. So yeah, the accuracy score is not coming as it says the best score, but yeah, I guess maybe yes. Um, let me ask one more time and then we should be done with the video. I ran the grid search. This is the output. Okay, now when I run the code with the code with the the suggested best parameters, I am getting the same 73 accuracy score. Maybe it was running on course, right? Multiple course. Same accuracy, correct? So we have this cross validation versus test train split. Oh, we do have small data set. Hyperparameter sensitivity, maybe we are doing overfitting. So it says we need to increase the training data set, use cross validation on final model. um, Further hypertune. So maybe we have the data is not that long, I mean that large. So yeah, so I think we learned something how to hypertune the model. And yes, thank you very much. Let's commit the code to our git repository and close the, I mean be done with today's video. So let's add the day 17. Let's commit the code, add day 17 code, uh, and push to the main branch. Let's go to our git repository and see if we can see the code here. And yes, we can see the code here. It looks good. So yeah, thank you everyone. We will come back and solve our next problem tomorrow.